All right, in this section, we're going to talk about homeostasis as a whole. You should be able to define homeostasis and provide an example, and distinguish between positive and negative feedback mechanisms. So, what is homeostasis? Homeostasis is the constant adjustment made by the organ systems to respond to the changes in the internal and external environments, while limiting too large of variations of the internal conditions that are required for life. This is ultimately going to rely on the nervous and endocrine systems, which are mostly responsible for internal communication. This is going to be maintained primarily through negative feedback mechanisms. So homeostasis is just the constant adjustment made by the organ systems to respond to changes in the internal and external environments. So things like maintaining blood glucose, pH, body temperature. If the condition varies too much, illness will be the result. So this is going to be ultimately coordinated through the nervous and the endocrine systems that are going to help maintain and regulate other organ systems. The nervous system is faster, but the effects of the endocrine system are much more long-term. The endocrine system is going to secrete hormones, chemical messengers that can travel in the blood and ultimately affect change that way. Now, like I said, this is going to be done primarily through negative feedback mechanisms. There are both negative and positive feedback mechanisms, but the negative feedback is going to be the primary mechanism used by the body, and it's going to have two components, a sensor and a control center. And the outputs of the system will turn down or off the production of the primary mechanisms at work. So it's going to function kind of like how a furnace works. So when the temperature in your house becomes too cold, your furnace is going to kick in and turn on until the house heats up. Once the house maintains or hits a certain temperature, the furnace will then kick off until the temperature drops back low below a common threshold. Once we go below the threshold, the furnace will kick back on. Your body is going to work the same way, and it's going to function very similarly to it's going to function in the same way to maintain temperature. So for example, if your temperature gets above normal, that stimulus, that increased temperature, is going to send a message to your brain. Your brain is going to collect that data and say, hey, this is not okay. We're going to need to respond to this and help lower our temperature. So for example, the blood vessels will dilate, your sweat glands will secrete in effort to keep your body cool. This will continue until your body returns to a normal temperature. If your body falls below the normal temperature, this is going to send the data to the control center, to your brain. Your blood vessels will constrict, burying themselves deeper in your body to help maintain an internal temperature. The sweat glands are going to become inactive. Shivering may even occur until your body maintains or reaches normal body temperature. So this is how a negative feedback system works. Basically, something happens, your body tries to correct it in order to balance it out. So we maintain an even keel. Positive feedback is going to bring about change in the same direction as the original stimulus. So for example, childbirth. In this case, the fetus's head will push against the cervix, which will stimulate signals that are sent to the brain. The brain will then secrete the hormone oxytocin, which will cause even stronger contractions. This causes more oxytocin to be released, which will increase the contractions even further. This is why contractions get stronger and stronger and closer together until the child is delivered. Now, positive feedback systems can be harmful in some situations. So in the case of a fever, where the temperature is, your body will actually signal a fever to start in order to fight off infection. However, the increased temperature can trigger a greater inflammatory response, which will increase your temperature further and further and further, and your body will just kind of keep increasing in temperature until that's brought into check. So here is just sort of an overview of all of the different members and all the different organ systems that are responsible for maintaining homeostasis. I recommend that you spend just a little bit of time looking at this diagram. I find it very helpful and very informative. All right, you should be able to define homeostasis and explain why it is so important to body function and summarize how the body systems help contribute to homeostasis.